In this example, we are going to use the component method. We are given three vectors, 25 meters east, 30 meters north, 10 meters at 30 degrees north of west. You are asked to find the resultant displacement using the component method. Okay, so the first thing that we have to do is to tabulate this because the component method that we are using is the tabulation method. There's no need for us to do scaling because this is the component method. Okay, so we tabulate D1, D2, D3. We create the table that would belong to column 1. Let's use the ruler to guide us in making a table. So the ruler here is just to help us create the table. You can also use Microsoft Excel if you want to find the answers. Okay. In the first column, you have vectors. And then in the second column, these are the X components. And the third column, you have the Y components or the Y part. And here you have the X part. Okay. So we list down each vector, okay, according to where they should be placed. Okay, so let's go to D1. D1, it says here 25 meters east. Now remember, the orientation that we have is this is north, south, and this is east, and this is west. Okay, so it says here D1 is 25 meters east. So there is no Y part, only the X part. And it's in here, it's heading to the right. That's why this is positive. So positive 25 meters. There is no uh, there is no Y component, so we just write down 0 here. Okay. For D2, it says 30 meters north. It has only a Y part, so it's going upward. So we put here positive 30. And there is no X component. There's no X part here because it's heading only straight up. Okay, so we put here 0. In the third vector, D3, you have 10 meters at 30 degrees north of west. Okay, so where is this? This vector here lies in the second quadrant. Okay, in the second quadrant. Now remember, in algebra, we were taught that for quadrant 1, you have the X part as positive and the Y is also positive. Here in the second quadrant, the X is negative and the Y is positive. In the third quadrant, both the X and the Y are negative. In the fourth quadrant, you have positive value for X, negative value for Y. Now we have to take note of this because when you when you put the values here, you have to include the sign. Okay, so since the third vector lies in the second quadrant, the X part should be negative. So negative, okay, 10, and the X part is given by cosine. So negative 10 cosine 30. And for the Y part, it says here the Y part is positive. So positive 10 sine 30. So the Y component is given by sine. Okay, so since this is north of west, meaning the angle open from the west heading towards the north. Okay, so when you break down the different components, okay, uh, if this is your angle theta, this is our 30 degrees. The one opposite it would be positive 10 sine 30. Okay, and the one adjacent would be negative 10 cosine 30. We use the calculator to get the value of the following. So let's have 10 times cos 30. We get 8.66. So this is negative. We put it in a parenthesis, negative 10.66. And this one, 10 times sine 30 is equal to 5. Okay, because sine 30 is 0.5. Now this is positive 5. Okay. Now what do we do with the broken down component, okay, of X and Y? We add this column here and we add this column here. So 25 minus 10.66 we get 14.34, and it's positive. Okay. Then for this one, you have 30 plus 5, get 35. Okay. The next step, so since we have already reduced this to one x value and one y value, the next step is to use the Pythagorean theorem to get the resultant magnitude. Okay, so the resultant magnitude, d sub r, okay, can be found using the Pythagorean theorem. Okay, let's do that. You get 37.8. Then we round this off to two significant figures. You get 38. And the unit we just follow, it says meters. Now we have the magnitude. We have to look for the direction. How do we find the direction? Our basis would be these two vectors here. It says that the x component goes to positive. Okay, in the positive direction. So positive 14.34. And it goes up. Remember, this one is just an estimate drawing, and it goes up 35 meters. So the resultant would be this one. Okay, this is 38 meters, right? And we would like to know the direction theta. We would like to solve for this. So we have to use tangent theta is equal to the opposite over the adjacent side, 14.34. So theta, okay, is equal to the arctan of 35 over 14.34. Okay, let's compute that. Shift tan 35 divided by 14.34. Close. This will give us the theta given is 67.72 degrees. Our agreement is to have two decimals. No, limit our answers to two decimals. This is the angle created, okay, by these two vectors. Now, what is the direction? Since our orientation is this is north and this is east, it's going to be 67.72 degrees north of east. Okay, this is our answer for the direction. Now, you always have to look for the direction because we're solving for the vector. So don't stop here. You have to do this one also. Okay, so the answer is 38 meters at 67.72 degrees north of east. Okay, that's it. Thank you.